In this video, I'm gonna walk through our project of delving into the Q&A network. We use text mining and graph analysis. And nowadays, Q&A platform is increasingly important for students, engineers, scientists sharing their knowledge and get their questions answered. So as users, we are interested in what are the discussed topics, how easily can we get our problems solved using such problems. As a developer, we are interested in the whether the problems users are facing and how they can take such information to improve the products and documentation. Our projects address such problems by extracting the topics out of large amount of posts and the topics distribution of each document. And we also predict the good quality answers by building a predictive model. The third part of the project, we visualize the network of questions to know what's the trends and relationships among the discussed topics. The project structure can be divided into two parts. The first part, we're gonna use Spark LDA to extract topic features out of all the post documents, and we combined the text features with non-text features to build a predictive model to predict the good quality answers out of other answers. The second part of the project, we implement our data, which is post users and text data, into the Neo4j database and run some queries to extract data using Cypher to get the data and visualize data using these three. And also we can use the data to build a simple recommender. The tools we use, I mentioned before, we use Python to cleaning text and conduct text analysis, and use Spark to conduct LDA models and other machine learning models. And we use Neo4j as our graph database, and we use these three to visualize the results. Our database is downloaded from Stack Exchange Data Explorer. We choose the data science categories to conduct our analysis. The data structure can be displayed in this diagram. We have users, which contains reputation, creation dates, some demographic data, and our posts can be divided into two kinds, which is questions and answers. All of the post contains ID, type, creation, title, body, except that Ask has one additional features, which is text. The nodes are connected through the arrows. The users can answer or ask a question, and ask nodes has the property of hashtag of different texts. Now I'm gonna discuss the algorithms we use. The first part of our project, which is text mining and classification, in the text mining, we're gonna use LDA to extract topics out of the documents. So the basic idea on the LDA topic model is that it assumes that each document was constructed from a distribution of different topics, and each topic has different distribution of words. LDA can influence the the words distribution of each topic and the topic distribution of each word. So the first step, we clean the text and generate the turn document matrix as the input of Spark LDA, and we use Spark LDA using Python API to get a number of topics we choose. And then we use the Scala API to get the topic distribution of each document. And the result, we display the 10 topic results in the word cloud graph as follows. So we can see that some topics are about language programming such as Python, R, and some topics is about modeling and machine learning and algorithm, and some topics is about processing data. The next part, we gonna build a predictive model to predict the good quality answers. In this database, some good quality answers are accepted by the people who raises the questions. So building a model to predict what answers are going to be accepted is equals as predicting the good quality answers. So the objective behind this is that as we have the result of the predictive model, we can use it to rank the answers according to its quality, as well as understand the successful features that a good quality answer has, so as to provide the direction to improve our system. As I mentioned, that the classification problem can be perceived as classifies the accepted answer and not accepted answer. So in order to predict the better results, we process our data. We delete some biased data, such as those data, those answers has the same asker and answerers, and also we delete those answers that have been edited after being accepted. Using the pre-processed data, we extract 5 different kinds of features. The first features represents the quality. It contains length, URL count, scores, which is upwards minus downwards, and the comment count. And the second kind of feature is the attitude, which is conducted by sentiment analysis. And the third kind of feature is time, which represents how quick a questions can be answered. And the fourth feature is reputation, which is the answer's reputation. And the fifth feature is the topic features generated before. The method we use is random forest. We conduct 5 different sets of features, which is we use all the 5 factors as our whole model, and we delete each category of features and run the model on the fourth remaining features, and the results can be shown in the table. And we can see that the model without topic features has the best result. It has a best AUC, F score, and precision. And from the table, we can see that deleting time features gonna affect the accuracy of the model significantly, and also the which means that time effect model is features is very important in our model. And also the second important feature is quality, and following by reputation, etc. The second part of our project, we implement the data to the Neo4j database. and conduct some visualization and a recommender. So there is a snapshot of our database, and we can see that the yellow dots are users and the red dots are answers, and the yellow dots with a date, it's questions, and this yellow dot, this gray dot is the text. I can show our database. So here is some demos of our new database. We have we have nodes, answers, asks, tags, and users, and we have 4 kinds of relationship, which is a person can answer a question and can ask a question, and a question has the tags, and a answer can answer questions. And if we click a node, we can see some connected dots related to it. So as we can conduct some graph analysis, such as conduct some queries and output some data out of it. And so next, I'm gonna show some examples of using this database to conduct some visualizations. So the first graph is we extract the text relationships out of the database and plot it using a force-directed graph. So in this graph, that each node is a tag, and the link between two tags shows that the two tags has been has been tagged in the same question, and the thickness of the link shows that how many same the number of questions that has both the tags between these two ends of the links. So we can see that in the middle of the cluster, there is strong connectedness between those tags, and at the outer range of the cluster, there is less connectiveness. So this graph shows that the connectiveness of the tags, and from the graph we can see that some tags is more connected and more heavily linked between each other, such as some nodes we are very familiar, like R, JavaScript, and Neo4j. So but one disadvantage of this graph is that in the middle of the cluster, that the tags are overlapped and intersect heavily. We cannot see clearly of how these tags is connected with other. So further, we dropped a edge bundling graph, which can be shown as the flow, and we can see how a tag is connected with other tags if if our mouse is hover over the word. We can see that, for example, Python is related with a lot of tags, and the thickness of the edges that links to Python can show the popularity of the tag. So using this edge bundling graph, we can see a popularity of tags and the connectiveness of tags. The third part of the implementation of the graph database is that we can use Cipher query to create some relationships easily from the database. So here is an example that we can use a query to find some recommendations to the questions that has no answer yet. So I conduct a query that has no answer yet and recommends the users who has answered the questions that has the same tags as the questions we want to find. So here is a simple result of the questions ID with some recommended users, and the tags are listed here as well.